On the next page, there are instructions for finding both horizontal asymptotes and oblique asymptotes from the formula. Okay, so let's first talk about horizontal asymptotes. Okay, first of all, you should know that the graph of a rational function can cross a horizontal asymptote. It's pretty rare, but it is possible that the graph of your function will intersect a horizontal asymptote. Okay, this is how you find them from the equation. Okay, so horizontal asymptotes are found by comparing the degree of the numerator to the degree of the denominator. Okay, and there are three different situations. Okay, so let me highlight this. You need to compare the degree of the numerator to the degree of the denominator. Okay, so the first case, okay, is if the degree of the numerator is smaller than the degree of the denominator, then the graph has a horizontal asymptote y equals 0, which is the x-axis. Okay. Keep in mind as we do this, remember vertical asymptotes, their equations are going to be x equals. If you're dealing with a horizontal line, its equation is going to be y equals. Okay, so let me highlight the important things here. Okay, if the degree of the numerator is smaller than the degree of the denominator, then your horizontal asymptote is going to be y equals 0, which is the x-axis. Okay, no work involved. Okay, it's automatically going to be the x-axis. Okay. The second possibility, okay, if the numerator and the denominator are of the same degree, then the graph has a horizontal asymptote at y equals, you need to make a fraction, that's going to be the number. You're going to take the leading coefficient of the numerator and divide by the leading coefficient of the denominator. Okay, so this is the case if the numerator and the denominator are of the same degree. You're just going to do this very simple computation. Okay, it's going to be y equals leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay, last case, the degree of the numerator is bigger than the degree of the denominator. Then the graph will not have a horizontal asymptote. Okay, so you got to keep these three rules straight. Okay, there is very little computation involved if you're finding a horizontal asymptote. Okay, you're simply comparing the degree of the numerator to the degree of the denominator. Okay, and the equation will be of the form y equals. Okay, if we go down now to talk about oblique asymptotes. Okay, these can be, these can happen. Okay, you may be new to these. Okay, so this is the slant asymptote. Okay, so it's going to be an asymptote that is a line with slope. Okay, first thing you should know, the graph of a rational function can cross an oblique asymptote, just like it can cross a horizontal asymptote, but you cannot cross a vertical asymptote. Okay, oblique asymptotes are also found by comparing the degree of the numerator to the degree of the denominator. Okay, so we've already taken care of what happens if the degree of the numerator is smaller than the degree of the denominator. It's going to be a horizontal asymptote. If the numerator and denominator have the same degree, it's going to be a horizontal asymptote. Okay, but if the degree of the numerator is bigger, you're not going to have a horizontal asymptote, and it opens you up to potentially having an oblique asymptote. Okay, so again, we're comparing the degree of the top to the degree of the bottom. Okay, in number 1 here, it says if the degree of the numerator is exactly 1 more than the degree of the denominator, then the graph has an oblique asymptote of the form y equals mx plus b. Okay, so for example, if you have some kind of rational function like this, I'm making this up. Okay, but see, in the numerator, you have degree 5, and then you have degree 4 in the denominator, and the degree of the top is exactly 1 more than the degree of the bottom. That means you're going to have an oblique asymptote. Okay, and the way you compute it, you're going to be asked to calculate it. You're going to have to give the y equals mx plus b. That is the oblique asymptote. It is found by using, unfortunately, long division. Okay, you're basically going to take you're going to divide the denominator into the numerator. Okay, I will go over that with you. Okay, secondly, and number 2, if the degree of the numerator is 2 or more bigger than the degree of the denominator, then the graph does not have an oblique asymptote. Okay, so you're only getting an oblique asymptote in a specific situation when the degree of the numerator is exactly 1 more than the degree of the denominator. Okay, at the bottom, okay, there's a very important note, so make sure you read this. It says the graph of a rational function can have either a horizontal asymptote or an oblique asymptote, but it cannot have both. Okay, so you cannot have a graph that has both a horizontal asymptote and an oblique asymptote. Okay, it's got to be one or the other, but it's also possible for your rational function to have neither. Okay. All right, so in the next example, we're going to do some practice with, being given the formula and having to compute either the horizontal asymptote or the oblique asymptote.